2-gang old work switch box extender is designed for use with 2-gang switch boxes. This particular model provides 125 cubic inches of additional electrical box space. It includes a 1/2-inch knockout in the back for cable entry. This specific extender accommodates up to 4/12 THHN cables. To install, place the switch box extender over the existing switch box. Use the included screws to secure it. Next, employ a hole saw to create a 1/2-inch opening in the wall. This opening is for the knockout to pass through. Route the cables through the knockout and into the switch box extender. Finally, connect the cables to the switches inside the switch box. If a larger capacity switch box extender is required, there are alternatives to consider. A 250 cubic inch 1/2-inch knockout 2-gang old work switch box extender is an option. Another alternative is a 500 cubic inch 1-inch knockout 2-gang old work switch box extender. The selection depends on the specific needs and the number of conductors requiring accommodation. When working with electrical wiring, always consult local electrical codes and regulations. Ensure all work is performed safely and correctly. If unsure, consult a qualified electrician. When running at least 4/12 THHN conductors in a raceway or conduit, understanding box fill calculations is essential to ensure compliance with electrical codes. Box fill refers to the maximum number and size of conductors, devices, and fittings permitted in an electrical box or enclosure. Firstly, NEC section 314.16 provides the rules for calculating box fill. Each conductor entering the box contributes to the total fill volume based on its size. For example, a #12 AWG conductor requires 2.25 cubic inches of free space within the box. Secondly, conductor fill is determined by the number of conductors in the box. This includes all conductors, such as hots, neutrals, and grounds, but excludes equipment grounding conductors under certain conditions. These are covered in NEC 314.16. b. Thirdly, device fill considers the space occupied by devices such as switches, receptacles, or equipment grounding conductors connected to one or more device. Each device counts as 2 conductors based on the largest conductor entering the box, as noted in NEC 314.16. c. Fourthly, clamp fill addresses the space occupied by internal cable clamps. One or more internal cable clamps count as 1 conductor based on the largest conductor entering the box, following NEC 314.16. a. Fifthly, support fittings fill concerns the volume taken up by support fittings. These are typically not applicable in standard switch box installations. For 4/12 THHN conductors, the calculation is straightforward. Each #12 THHN conductor requires 2.25 cubic inches of free space, totaling 9 cubic inches for the conductors alone. If the box contains a single device such as a switch or receptacle, it is counted as 2 conductors. This adds an additional 4.5 cubic inches. If there are internal clamps, they would add another 2.25 cubic inches. In total, this could require 15.75 cubic inches of space. Given this calculation, a standard 2-gang box may not provide enough space to accommodate the 4/12 THHN conductors plus devices and clamps. This is where using a box extender is useful, as it will provide the additional cubic inches needed to meet NEC fill requirements. Always consult NEC table 314.16. For specific conductor fill requirements based on wire size. Remember that exceeding the maximum box fill can lead to overheating and potential electrical hazards. Therefore, selecting the correct box size or using an extender is crucial for ensuring safety and code compliance. To elaborate on box fill calculations, consider a situation with 4/12 AWG conductors, 1 switch, and internal clamps in a 2-gang box. Firstly, the 4/12 AWG conductors require 9 cubic inches of space. Secondly, the single switch counts as 2/12 AWG conductors, adding 4.5 cubic inches. Thirdly, the internal clamps count as 1/12 AWG conductor, adding 2.25 cubic inches. The total required space is 15.75 cubic inches. Many standard two-gang boxes do not have this much internal volume. Therefore, using an extender is necessary. If, instead, the conductors were #14 AWG, the calculations would be different. The fill volume for #14 AWG conductors is 2 cubic inches each. Thus, 4 #14 AWG conductors would require 8 cubic inches. The switch would still count as 2 conductors, but this time as 2 #14 AWG conductors, adding 4 cubic inches. The internal clamps would also count as 1 #14 AWG conductor, adding 2 cubic inches. The total required space would be 14 cubic inches, which might fit in a standard two-gang box. Always check the box's markings for its listed cubic inch capacity. This is usually stamped on the inside or outside of the box. Box extenders are particularly useful in remodeling or retrofit situations where it's impractical to replace the existing box. They allow you to increase the box's capacity without disturbing the surrounding wall or structure. In addition to cubic inch capacity, it's important to consider other factors. These factors are the box's material, mounting method, and suitability for the environment. Plastic boxes are suitable for dry locations. Metal boxes can be used in various environments, but must be properly grounded. The mounting method depends on the wall construction. Old work boxes use clamps to grip the wall. New work boxes are nailed or screwed to studs. Ensure the box is listed for its intended use. This means it has been tested and certified by a recognized testing laboratory such as UL or ETL. Proper grounding is also essential for safety. All metal boxes must be grounded to prevent electrical shock hazards. This can be achieved by connecting a grounding conductor to the box's grounding screw or clip. When running multiple circuits through a single box, ensure that each circuit is properly identified. Use color-coded conductors or labels to distinguish between the circuits. This helps prevent confusion and accidental energization of the wrong circuit. Also, be aware of dirting requirements when multiple current-carrying conductors are bundled together. When more than 3 current-carrying conductors are bundled in a raceway or cable, the ampacity of each conductor must be reduced according to NEC Table 310.15. B3. A. This is to prevent overheating of the conductors due to their close proximity. Always consult the NEC for the specific dirting factors. Remember that electrical work can be dangerous. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, consult a qualified electrician. In summary, a two-gang switch box extender with a 1/2 inch knockout is a useful device for increasing the capacity of an existing electrical box. It can accommodate additional conductors, devices, and fittings. When using a box extender, always calculate the box fill to ensure compliance with the NEC. Choose the appropriate box size and material for the application. Ground the box properly. Follow all safety precautions. If you are not qualified, consult a professional electrician. Let's delve further into the practical aspects of using a two-gang switch box extender, especially when dealing with 4/12 THHN conductors. Firstly, before beginning any electrical work, ensure the power to the circuit is completely turned off at the breaker. Verify this with a non-contact voltage tester to confirm no voltage is present at the switch box. This is a critical safety step. Secondly, carefully remove the existing switch or receptacle from the box. Disconnect the wiring, taking note of the connections for proper reinstallation later. A picture can be useful as a reference. Thirdly, assess the existing box. Check for any damage or loose connections. If the existing box is damaged, it may be necessary to replace it entirely rather than using an extender. Fourthly, prepare the extender. If it has a knockout that needs to be removed, do so using pliers or a screwdriver. Ensure the knockout is clean and doesn't leave any sharp edges that could damage the wires. Fifthly, install the extender over the existing box. Align the screw holes and use the provided screws to securely attach it. Ensure the extender sits flush against the wall surface. Sixthly, route the #12 THHN conductors through the knockout into the box. If necessary, use a plastic bushing or connector to protect the wires from abrasion where they enter the box. Seventhly, make the wire connections. Connect the wires to the switch or receptacle according to the original wiring configuration. Use wire connectors that are rated for the size and number of conductors being connected. Eighthly, carefully fold the wires into the box, ensuring they are not overly crowded or pinched. Arrange them so they don't interfere with the device when it's installed. Ninthly, install the switch or receptacle back into the box. Secure it with screws, ensuring it's flush with the wall surface. Tenthly, install the cover plate. This provides a finished look and protects the wiring from damage. 11thly, turn the power back on at the breaker. Test the switch or receptacle to ensure it's working properly. If it doesn't work, turn the power off and recheck the wiring connections. When working with cinder block walls, creating the 1/2 inch opening for the knockout may require special tools. A hammer drill with a masonry bit is typically used to drill through the cinder block. Be sure to wear safety glasses to protect your eyes from flying debris. Also, be aware of any potential obstructions within the wall, such as pipes or other wiring. If you encounter any obstructions, it may be necessary to adjust the location of the knockout. In addition to the standard switch box extender, there are also adjustable extenders available. These extenders allow you to adjust the depth of the box to accommodate different wall thicknesses. This can be useful in situations where the existing box is recessed too far into the wall. When selecting a switch box extender, consider the material it's made from. Plastic extenders are lightweight and corrosion resistant. Metal extenders are more durable and can provide better grounding. Choose the material that's best suited for the application. Also, be aware of the listing requirements for switch box extenders. The extender should be listed by a recognized testing laboratory such as UL or ETL. This ensures it meets safety standards and is suitable for use in electrical installations. In some cases, it may be necessary to use a deeper switch box instead of an extender. A deeper box provides more space for wiring and devices. This can be useful in situations where the box fill is excessive or where there are multiple circuits in the box. When using a deeper box, ensure it's properly supported and secured to the wall. It's also important to use the correct type of screws for securing the box to the wall. Use screws that are designed for use with electrical boxes. These screws have a blunt tip that prevents them from damaging the wiring. Always follow the manufacturer's instructions when installing a switch box extender or a deeper switch box. The instructions will provide specific information on how to install the device properly and safely. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, consult a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. By following these guidelines, you can safely and effectively use a 2-gang switch box extender to increase the capacity of an existing electrical box. This will help ensure that your electrical installation is safe, code compliant, and reliable. Remember to always prioritize safety and consult with a qualified professional when needed.